You might have been told that if you connect to an open, unencrypted, public Wi-Fi to avoid using your personal accounts or send data that are confidential because everything is sent in a clear text and can be sniffed and people can steal your data. But how does that really work? In this video, we will explain how exactly this can work, like how people can sniff your data, how and why it is happening only in Wi-Fi and not wired. So we're gonna talk about little bit that, okay? And if you're ready for some network nerding, consider watching. If you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing. Hit that like button, hit that bell icon so you get notified if I make a new software engineering video. That's it. Let's just jump into the video, guys. So here's what we're going to talk about. I need to talk about, in order to talk about wireless, we need to talk about wired, how things are work, right? And wired, we're going to talk about wired router, how actually that works, and how actually the switching is working, and how it's actually being considered more secure than wireless. We're going to talk about that. We're going to talk about wireless in general, how that works, and finally we're going to talk about packet sniffing, different bandwidth, 2.4, 5G on the wireless, and how is that exactly this is happening, right? So let's just jump into it. Okay, so here's a simple configuration, right? Going back to early 2000, maybe before that, before the wireless, right? We have a nice router and we have, ignore those antennas. Let's assume this is just wired, okay? Or maybe it supports both, but there's like ports. How many ports do we have? Six ports here, okay? And we have these four machines and they are literally plugged into the router, okay, using this, and this is connected to the internet, and this is my configuration, okay? So if I connect that, obviously I'm gonna get each of those guys are gonna get an IP address 192.168.1.5.4.3.2, okay? And this guy is gonna get 1.1. This is called the gateway. We're gonna explain what is that. Each one gets a MAC address, obviously, A, B, C, D, E, and this is an outside network, say MAC of F, and this is 44124. This is my external IP address of the router because it has public interface. So 44124, that's my public IP address. This is internal. Guys, if you want to learn more about public and private IP, I made a video here. I'm gonna reference it just to talk about really how this is working. All right. So more details, click on that video. But that's what I have, wired router. And let's assume, okay, so we have a gateway. We talked about the gateways a little bit. So all of those guys are connected to one router that allows us to connect to the outside network because this is an internal network. So if you want to connect to outside, you delegate that to the gateway. More coming. Okay, we're going to talk about that more. Okay, so what happens here is that port that we connect to, like this is connected to port 1, the router or the switch in this case, what it does is it associates the MAC address of that port, right, with the destination computer. So this machine, it knows that, oh, port 1 has this machine and this MAC address, and there's a reason for that. Okay, port 2 has nothing. Look at that, it literally has nothing, right? So it's red. Okay, port 3, hey, there's C. Okay, port 4, there's D. Okay, port 5, nothing. Port 6, there's E. Okay, and it literally builds a table, and it's called switching table. Okay, and this is the switch part of the router. Okay, you can obviously get just switches that does do that job, but routers almost most of the time does both routing and switching. So we're talking about switching now. Okay, and okay, what are we talking about here? Why are we assigning numbers in this? What's the use of this? We're going to talk about that. Okay, let's assume you have a web server internally running on 9.2.168.1.2 and you want to connect it from this machine. So 5 want to connect to 2. I don't know, some internal service on your work, you want to connect to that service. Okay, so how that usually work is you want to first, you have the IP address, okay, 192.168.1.2. I want to connect to that guy. Okay, the first thing you need to know is the MAC address. You have to, otherwise you cannot send data on layer 2, okay, because that's the most important thing. That's the most important thing. You need to know the MAC address to send stuff to it. Okay, so how do you do that? ARP, address resolution protocol. We do an ARP, we get the MAC address, and we have the MAC address B. So I know that I am E, I want to connect to B. So I shove my data, my GET request, my POST request, HTTP request into packets, which is destined to the IP address 192.168.1.2. But the most important thing is all shoved back into a bunch of frames that all address to B, okay? And there is one wire coming out of my machine, right? And I'm sending that electric signal there with all this data. And it's going there. The router will see, hey, something's coming from 6, from E, okay? And it looks at the frame and say, oh, this guy want to connect to B. I know where B is. B is right there. I am going to only forward switch those packets, those frames to this port, okay? So now those two guys never actually gets any of this data because it has been switched. So less bandwidth, right? Obviously more secure because that's the only those two only the guys that actually sees the data if they are destined to it. Okay, and there's like less bandwidth flowing through the network, which is pretty cool. Hubs, on the other hand, the older technology, are dumb, right? Are dumb switches. Essentially, when anything receives it, it will just say, hey, I don't know, I have no tables, I have no software, I don't have this magic table, okay, so I'm gonna send it to everywhere. So hubs are less secure in that case, and they consume a lot of bandwidth in this case. Okay, makes sense. Okay, all right, let's spice things up a little bit, guys. Let's spice things up. I want to connect from 5 to 44124. This is not even in my network. This is something outside, right? Because it's not in my subnetwork, right? If you do /24, this is not in my subnetwork. So I cannot do an ARP on 44124. I cannot do an ARP. I cannot find its MAC address if I wanted to. So that's where, if you really, as a computer, you don't know where to connect to and it is something outside your subnet, you send it to a person that can connect you to. Who is this person? Who is this machine? It's the gateway. Any packet that you don't know how to send it to, you shove it to the gateway. How do you do that? I am destined to 44124. Okay, I'm destined to this IP address, but the MAC address, you put the MAC address as the gateway, which is, I know that. I can do an ARP on 192.168.1.1, find the MAC address A, send that packet to MAC address A, okay? And which the router says, oh, you're sending me stuff. Nobody sent me stuff. Because look, if you think about it, nobody sends the router packets. Everybody's destined to somewhere else. You want to go to Google, you don't care about your router. So the router really appreciated it when you send it stuff in this case. But he opens, or she opens the data, okay? I don't know why I'm using genders with routers, okay? So they, okay, opens the packet, the frame, says, okay, oh, this is for me, it's A. But it opens it and says, oh, you want me to? Okay, you actually want to go to this guy? Oh, okay, I get it. I'm ugly. I know. Okay, so once it just does this Russian doll thing, so it just opens up the packet, right? Because that's what the packet, networking packets, it's just a Russian dolls over Russian dolls, right? So opens up and it finds that it's actually not intended for you. You're just, because I didn't know where to send, I send it to you. Right? Don't flatter yourself, okay? So don't flatter yourself. This is not really for you. All right. So the router just, okay, I'm gonna send it over. It does some natting here. It does the NAT, which is a network address translation, because it says, okay, you want to connect to the outside world, cool, I get you, but I cannot send you naked like that because nobody actually can understand this internal IP address. I'm gonna use my external IP address and communicate with the outside world. It does change the packet a little bit. I talked about NAT. Go ahead and check that a little bit if you want detailed stuff again, guys. All right. Okay. So, and this again, those guys never go to this packet. So those 4 and 3 and 2, they don't know that I actually connected to google.com or 44124, okay? They don't know that, which is pretty cool. Let's talk about wireless. Wireless, on the other hand, there's no wires, right? So there's no cable that I can direct my electricity or fiber optic and just go there. There's nothing like that. If it's a bunch of wavelengths, it's just the waves going on the air, and everybody can see them, everybody can send them, so anybody can tune to a frequency and see and capture stuff, right? That's the problem with the World War II, right? All the Enigma stuff and encryption. Everybody can just capture everything in the air, right? There's no wires that you can tap into it, right? And here's a configuration. Let's say I don't have wires anymore, right? All these guys connected to this wireless, right, network, and they're sending stuff over the wire. So there's no ports, there's no smart MAC address translation, and there's nothing. Yeah. So what happened? Let's go through the two scenarios that we went for with wire, but with wireless. What happened? If 192.168.1.5 gonna connect to 2, it does exactly the same thing. Okay, it does an ARP request on 2. Okay, and it finds that it's the MAC address of B. If it's the ARP cache is cache, then it knows that 192.168.1.2 is B. It doesn't have to do with the ARP. It then sends the request as, hey people of this band wireless, who has the MAC address B? So it's gonna send it over. But guess what? Everybody will get it. Everybody that is connected to this wireless will get it. But I don't know if you saw the animation. The software is designed so that if you receive something that is not intended to you, frame-wise, layer 2-wise, then please go ahead and drop it. That's not for you. I'm sorry. Drop it. So the router, let's just do it again. Okay? The router gets it. This guy gets it. This guy gets it. But drops. But they say, ooh, something for me. Okay? So it's actually for B. So it keeps that packet. It opens the Russell doll, finds there's an Untitled TCP. Oh, there's an IP. Oh, there's a port. Oh, you're going to my HTTP port. And then bleh, serves it and again send it back. Does it the same thing. Okay? Sounds legitimate, right? That's why there's a little bandwidth going on, right? Because you're sending a data, everyone gets it. That's the problem with wireless, okay? And that's the trick here. Everyone gets it, okay? But they're supposed to drop it. Suppose, quote unquote, supposed to drop it, okay? Let's talk about another scenario where we want to connect to outside world, not internally, but outside. Do everybody gets my request if I am connected to outside world? Well, let's check it out. If outside world means 44124 doesn't ARP request, we cannot find that, so we send it to the gateway. The gateway address is A. So yeah, who here have A gateway A? Who have not gateway? Just who here have the device MAC address A? Blah, boom, 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 boom. Everyone gets it. Okay. But the router gets to keep it because he's the intended party, okay, the frame, okay. Guys, if I'm talking from frame and packets and you're a little bit confused, go watch my OSI model, right? I talk details about actually layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7, okay, all of them in details from a software engineering point of view, okay, because I'm not a network engineer. I don't talk about ones and zeros and detailed headers of how they are sequenced. I talk about the higher level stuff, and I try at least, okay. All right, so router gets it, and it does a thing, NAT it up, send it up to the server, and gets the results, send it back, and that's it, okay. So the same thing. So everybody actually gets it, but they're supposed to drop it. Let's say we have a bad actor, someone who actually knows networking, have some special software that actually tweaked it a little bit, so they don't actually drop the packets. They just receive everything I want because, hey, guess what? They're connected, they're legitimate, they're cool, right? But they have just this software that is a little bit modified that they don't drop stuff. They keep it. And they keep it, that means they can open it, right? We're talking about different encryption versus unencryption. Let's talk about non-encrypted stuff. This is public Wi-Fi. And you're visiting an HTTP service, which is also not secure. There is no TLS going on. Okay, let's talk about simple stuff. So if you're doing that, then same thing. I want to send it to 44. Okay, this is intended to the gateway, right? But this guy is bad. He just actually keeps that packet. So your GET request, which is intended to this, the 4412, right? Entered to that MAC address. This guy gets it. He opens it up, right? Or she, right? And then looks it up. It's not encrypted, so opens it up and then looks like, oh, there's an IP address. Oh, you're going to 44124. You nasty. You're going to that site, huh? Okay, let's open it up. What do you have? Oh, this port 80. Oh, you're browsing the web. Okay, let's open it up. More. What's in the packet? Oh, there's a GET request. Oh, you're going to that link, that page, that index.html or whatever path, okay? Because it managed to open all that because there's no TLS. It's literally not encrypted. And there's two encryption level guys here, right? The Wi-Fi level encryption, all right? And there is the TLS protocol encryption, okay? And we talked about TLS. It's very important, these two things, okay? In this case, I am not encrypted because I'm public Wi-Fi, right? And the second one is also I am not encrypted TPS, all right? And we can send it over. Before we go to the summary, let's consider the encrypted path. I'm connected to google.com, which is HTTPS, okay, which is secure. There's a TLS going on. So those guys, this guy will get the packet, then we'll get the frame, we'll open the frame, we'll see the IP address, right? We'll see that you're going to 44124. They can see that, but the content of the TCP packet is encrypted, is garbage. It tries to open it, tries to make sense, and it's encrypted. It cannot decrypt it because it doesn't have the private key of the or the symmetric key, right? It doesn't have any of these keys. So we talked about TLS, guys, right? Remember, I'm not going to go into details. So it cannot really. So if you're going to the banking website on a public Wi-Fi, yes, the banking site is encrypted, right? But is public. So those guys, someone can sniff your packet, but by default, they cannot read it. That being said, there's something called a man-in-the-middle attack, okay? I have no idea why it's called man-in-the-middle attack, right? I have some theories. It's either someone is misogynistic who decided to say, okay, you know, one woman cannot carry on this attack, so only men can do that. Or my second theory is actually a woman came up with that kind of attack because men are cheat, they manipulate things, and they cannot be trusted. Okay, so pick your story. I have no idea. It's called Man in the Middle. It was called before I was born. I have no idea. Okay, pick your story. Okay, so Man in the Middle attack is essentially this guy, if he's fast enough, right, or gal, if they're fast enough, it can listen to the TLS handshake and inject itself there and act like a participant between those two. So essentially, it will establish two TCP connections between him and the client and him and the server, and everything goes through them. So it's still the encryption will still be there, right? So the certificate of this guy will be received by this client, right? So you'll still appear to be encrypted, right, and secure, but under the hood you're under attack of the man in the middle attack. So how do you find if you are a portion of the man in the middle attack? Let's go to a browser and show you something here, okay? So if I click here, let's go just here, literally, okay? And then look at that, okay? If you click on that guy, okay, if you see this, that means you're secure, but you really have to click and see the certificate. Okay, there's a certificate, this is valid, but go the additional step and click, ensure that this is whoever owns that certificate is actually trusted. Oh, this is coming from Google Internet Authority, G3, Google.com. I can trust this guy, right? If you do see a lock, but you're going to Google.com, but the certificate is from shady.com, then you have been, sir, you have been man in the middle. Okay? You have been man in the middle real hard. Okay? So that's essentially, in a nutshell, the man in the middle attack. So still, it's not secure to connect to public Wi-Fi's and exchange it, because some people can do, and they have done, man in the middle attacks, okay, on public Wi-Fi's, right? So you can find out, right, but it could be too late, right? So avoid using public Wi-Fi. Encrypt. If it's encrypted, this guy will have harder time to, because they have to go through 2 layers of security. The first one is just decrypt the Wi-Fi, and then after they decrypt the Wi-Fi, they go and have to decrypt the packet, the TCP packet content, right? So a lot going on, right? So he's probably said, okay, you're not worth decrypting. It's not worth the time. Okay, I might just go somewhere else and hack somewhere else. Okay. Bad actors. So guys, how can you browse securely in a public Wi-Fi? We talked about all the bad things that could happen in an insecure, free cafe Wi-Fi, right? But one of the solutions that can prevent you from getting sniffed on this public Wi-Fi or any internet connection, to be honest, is using a virtual private network, VPN. And we talked about VPN and how it actually works. We made a dedicated video about TCP tunneling that actually describe one application of tunneling is actually VPN. We talked about details there. I'm going to reference the video here for you guys so you can go and check it out. Summary. All right. Wired router, wireless router. Okay, we talked about how wired router works. We talked about wireless. We talked about switches. We talked about hubs. We talked about wireless router and how data is sent and it's just literally just floating in the air. How can people sniff back? We talked about bandwidth, Wi-Fi, 5G, and 2.4. 2.4 is essentially has a longer range, but the bandwidth is very low, and it can get saturated real quickly, especially with all this packets broadcasting almost, right? It's not really broadcasting, but it's actually broadcasting. I don't know how to explain it. 5G has a shorter range, so but it has more bandwidth, so it actually can be faster. Okay, if you're within range, obviously. Okay, so encryption and encrypted, we talk about all that stuff. All right, guys. Hopefully you enjoyed this video. If you did enjoy it, give it that like button, subscribe, hit that bell icon so you get notified of any video about software engineering in this channel. And I'm going to see you in the next one. You guys stay awesome. Goodbye.